In 10th standard physics, the chapter electromagnetic induction has the weightage of 4 marks in the SSLC examination. In this chapter, the concepts that are covered are fundamental concepts, which include the topics like electric current, measuring devices, electromotive force. Next is meaning of electromagnetic induction or EMI, dynamo and motor. Under meaning of EMI, the subtopics are Faraday's experiments, factors influencing induced EMF, and Faraday's laws. Dynamo includes dynamo rule, AC dynamo, and DC dynamo. In motor, the subtopics are DC motor and motor rule. Let us know about the real-life connects on some of the concepts under EMI. Under fundamental concepts, we will learn about measuring devices. Voltmeter is one such device which is used to measure voltage. Usually in villages or rural areas, the bore wells are attached to pump houses. These pump houses are fitted with pump set starter in which voltmeter is fixed. Before switching on the pump, the voltage is checked on voltmeter. Under meaning of electromagnetic induction, we will understand what induction is. Electrical induction means without physical connectivity, current is induced in a conductor. This technique is very much useful in modern age, efficient systems of cooking through induction stove and induction-based cooker. An induction stove uses induction heating for cooking, in which heat is generated directly by the method of induction in the vessel, unlike the electrical coils or burning gas. All telephone earpieces and many telephone microphones use the concept of induction. Plastic and glass containers are sealed by the process of induction sealing so that they are airtight. Under dynamo, the most common application which you have seen or experienced is the cycle dynamo. In cycle dynamo, as you pedal faster, the bulb attached to it glows brighter. Motors are one of the important inventions of all times. Most of the modern electrical gadgets have motors in them. The most recent use of motors is in robotics or in robots. Observe this video. Electromagnetic induction. In electromagnetic induction, the fundamental concepts are very essential to understand the concept of EMI. Now, let us know them. Let us know few fundamental concepts. Electric current. The flow of electric charges constitute electric current. You can see that the electrons freely move through a conductor when connected to a battery. Potential difference. Charge flows when there is a potential difference between 2 points of a conductor. Electrical circuit. Electrical current flows in a loop or in a circuit. The image shows a simple electrical circuit. The circuit has four important parts: a power source, say a battery, a conductor, the load which can be the light bulbs, and a switch. An open circuit condition occurs when the path of current flow is interrupted. With an open circuit, current will not flow. A switch is a device that enables a person to open or close the circuit. Voltmeter, an electrical device, is connected across the circuit to measure the potential difference. Galvanometer is connected in series to detect the presence of electric current, and ammeter is connected to measure the current. Let us know some of the electrical devices with their use and unit of measurement. Firstly, voltmeter. It measures potential difference across a terminal. The SI unit of potential difference is volt, denoted by capital V. Ammeter measures electric current and galvanometer detects the presence of small current. Current is measured in amperes, denoted by capital A. Now, let us go through some common SSLC questions with tips and detailed answer. Question 1. Volt is the unit of which of the following quantities? Your options are A. Electric current and potential difference, B. Potential difference and electromotive force, C. Electromotive force and electrical resistance, and D. Electrical resistance and electric current. Here is a tip to answer this question. Since potential difference, electric potential, and electromotive force are one and the same, the common unit to measure all these is the volt. So, the correct answer is option B, potential difference and electromotive force. Electromagnetic induction, EMI. Additional information. Construction and working of AC dynamo. It has an armature, which is the rectangular coil of insulated copper wire. The ends of the copper wire are connected to slip rings R1 and R2. These slip rings are attached to carbon brushes B1 and B2, which are in turn connected to a load, say a lamp. It is then placed in the strong magnetic field. Now, let us understand the working of this dynamo. When the armature rotates, say in clockwise direction, CD of the armature moves up and AB moves down. D is connected to R1 and that in turn is connected to brush B1. A is connected to R2 and that is connected to B2. Hence, according to right-hand rule, the current flows in the direction ABCD in the armature and B1 to B2 in the external circuit. Now, during the second half rotation, the current flows in the direction DCBA in the armature and B2 to B1 in the external circuit. This means the direction of the current in the external circuits changes every half rotation. This is called alternating current. Construction and working of DC dynamo. It has an armature, which is the rectangular coil of insulated copper wire. The ends of the copper wire are connected to split rings S1 and S2. These split rings are attached to carbon brushes B1 and B2, which are in turn connected to a load, say a lamp. It is then placed in the strong magnetic field. Let us understand the working of DC dynamo. When the armature is made to rotate in clockwise direction, the magnetic field linked with the coil changes. This induces an electric current in the coil ABCD. During the first half of the rotation of the armature, according to left-hand rule, the current flows along ABCD. As D is in contact with S2 and S2 to B2, the current flows from B2 to B1. During the second half of the rotation of the coil, the current flows in the direction DCBA. Now, A is in contact with S1 and S1 is in contact with B2. Hence, the current again flows from B2 to B1. This type of current is called direct current or DC. Construction and working of DC motor. It has an armature, which is the rectangular coil of insulated copper wire. The ends of the copper wire are connected to split rings S1 and S2. These split rings are attached to carbon brushes B1 and B2, which are in turn connected to a load, say a lamp. It is then placed in the strong magnetic field. Let us understand the working of DC motor. When the current is passed through the coil in the direction ABCD, according to Fleming's left-hand rule, AB tends to move downwards and DC upwards. These forces acting on AB and CD form a couple. Now, they begin to rotate. When the coil completes the first half of its rotation, S1 comes in contact with B2 and S2 comes in contact with B1. Now, the current flows in the coil in the direction DCBA. Due to the couple formed, coil continues to rotate in the same direction. Thus, electrical energy is converted to mechanical energy. To understand the meaning of couple, here is a simple experiment.